Hello and welcome to the last week of the Oktoberfest. Today is Thursday, meaning it is Data and AI Day, and this is the very first session of the day. We have 7 more sessions for you today, so we hope that you will stay with us. But for now, to kick this day off, we are starting with the very interesting topic with very interesting speaker. So we start with deep dive into SAP Business Data Cloud, and who could do this better than the CTO of Business Data Cloud, Bjoern Friedmann. My name is Vitali. I'm one of the developer advocates who bring this event to you, but knowledge is shared by our very special experts. Björn, let me hand this over to you.
All right. Thanks, Vitaly. So very warm welcome from my side as well. And thanks for the introduction, by the way. My name is Björn Friedmann. I'm the CTO for Business Data Cloud, which means I'm responsible end-to-end for the architecture of Business Data Cloud. And today, it's my pleasure to also give you a deep dive into the architecture behind Business Data Cloud. And I also want to share with you how we solve the data integration problem for the entire SAP world. So before we go into the architecture, let's do some level setting and see actually why we introduced Business Data Cloud and also why we build it in a way as we did it then basically. So if you look at the situation in today's big enterprises, we typically see very similar situations no matter to which big customer you're talking to. So you have a lot of data in these enterprises. This data is typically very fractured. It's often siloed in various solutions, be that now from SAP, but also from non-SAP vendors. And on the other side, you have the decision makers in the enterprise, which actually need to take decisions, informed decisions based on data. And in order to allow this, you then typically need technology experts who are actually, managing the data integration on behalf of the customer. So it's typically either big customers just acquire some services from vendors, or they do it on their own. And it's typically a very heterogeneous landscape, and very often this landscape is very fragile. So if you have pipelines running, managing data, moving from A to B, these things are super fragile and things can break in between. Yeah. So for instance, if you change something on the source side, some data sets, some structures of the data, you again have to manage your pipelines and react on these changes. Yeah. And what that ultimately means is the time to decision making becomes bigger and bigger and longer. And therefore, we had to find a way how we can bring the data now focusing on the SAP data first, but also allowing for non-SAP data very close to the decision-making processes. So basically, this data management is something which we now offer with Business Data Cloud as a managed service. And for SAP-based data products, and I will talk about data products in a second, what that is. For SAP data products, we automate this fully so that customers can easily tap into their data, but also combine their SAP data with non-SAP data. In order to achieve this, we also have architected Business Data Cloud around an open ecosystem, which also allows for integration, for instance, with vendors like Databricks. Yeah. So the most important topic for the Business Data Cloud is now actually how can we make sure that data from various sources can be harmonized and streamlined in a way that it can be easily consumed, both for analytics and decision making, but then also ultimately to enable and unblock AI processes to really make more meaningful insights on top of data. Before I go there, let me also introduce the friction points which we see as of today. Yeah, and why we believe that pure replication is by far not enough. So if we look at the various buckets of data which we find typically in a normal customer environment, you see that there's SAP Business Application Data, but you also typically then find a wide variety of things like sensor data. There is a ton of Word and Excel files. There's also partner or ecosystem applications. Very often we also find flat files. And these data buckets, they come from different sources. And what then typically happens is you start to copy data from left to right. You start to run pipelines which try to massage and manage the data. You try to harmonize the data, but it's a very tedious and very error-prone mechanism at the end of the day. And ultimately, taking then decisions or taking business insights on top of this data is very fragile as well. Because you need a lot of personas being involved. You need developers who are able to provide these pipelines. Then you typically need data modelers and engineers who try to make sense out of the raw data, which you typically extract. And ultimately, what you need to do, for instance, especially if I look at SAP systems, you need a way how you can preserve the semantics. So if we look at a very prominent table from SAP, actually the AC.A table, and I guess most of you should know this table. This table has hundreds of columns in itself. And even then within the columns, there is various settings like Boolean values, which in ABAP typically is an X. So it's a jar value. It's not actually a Boolean value. And in order to now really use the data coming from this table in a consistent way, you even have to know how you need to, well, how you need to tweak the data or analyze the data based on some settings which are in the columns. Yeah. Now, all of this can be managed manually, so to say, but as I said, it's very error prone. And this is now exactly where Business Data Cloud kicks in and where we then actually want to provide value ultimately also then for the AI world in order to make this a reliable and meaningful engine to solve data integration problems for our customers. Yeah. So now what is actually Business Data Cloud? So taking into account what I just explained, and let me start at the bottom, and I now focus on the SAP stack, but it also caters for the non-SAP stack. On the bottom part, you see the various applications, which we actually provide on our business technology platform. Business technology platform, BTP, is the harmonization layer, where we have common and shared services. For instance, and that will become very important when we look at the architecture from Business Data Cloud, we have services like Unified Customer Landscape, which actually manages and orchestrates trust across the entire stack of a customer. UCL, that's the abbreviation of it, actually is also then one of the key architecture principles which we applied in Business Data Cloud in order to fully automate the setup, including trust setup. But BTP also offers other services, and in the end, it's also our abstraction layer in SAP to abstract away all the complexities from various hyperscalers. So by design, Business Data Cloud runs on multiple hyperscalers. It basically follows the same hyperscaler strategy as we do with BTP as such, and therefore it's going to be available in all major hyperscalers in this world. Now on top, you find the AI layer, where actually now in the light of the agents which we currently see, we actually want to enable agents which have their specific business knowledge, like CX agents or finance-based agents, but also HR or supply chain agents. We want to enable these agents. And we also want to enable our customers to create their own agents on top of this. But the agent needs proper data in order to really take action on top of the data. Now, instead of integrating the agents one-to-one with all the business applications, which we see on the bottom side, we introduce a harmonized layer, which is basically Business Data Cloud, to manage the full data integration flow. Yeah, so Business Data Cloud is the glue piece between the business applications but also then the AI on the upper layer, but ultimately also then for the business user in order to take decisions. And if we double click a bit on Business Data Cloud and the components which we offer out of this, what we basically find is that data products is actually our managed solution, our managed offering towards the consumers like business users, like AI. Yeah, data products introduce a harmonized interface. Data products also introduce full semantic capabilities, which we actually derive from the source systems. And we base the primary persistence of data products on a full lakehouse architecture. That means the persistence of the data products is an object store, which is managed by SAP. Now it's based on HANA Data Lake files, which is our abstraction layer on top of hyperscaler object stores. And it also allows to onboard customer managed object stores, be that now through Databricks, for instance, but also from other partners, but also from third-party object stores, which customers might already have. Yeah, so keep in mind the primary persistence for a data product is the object store layer. Once we manage now, and there's a one-time replication from the LOB source system into the object store, and this replication is actually on purpose because we need to make sure that the downstream consumption, be that now for analytics, intelligent apps, which I will introduce in a second, but also then from Databricks, for instance, that this is independent from the source system, because very often we also see then situations where the source system might get under heavy load if you have a lot of downstream consumption. So therefore, on purpose, and in order to manage now a fully hydrated set of data products across the entire SAP landscape, we put this object store in the middle, so to say, in order to decouple the various scenarios. Now, in BDC as such, customers find a component which we call BDC Cockpit. This is actually the administration environment for customers where they can manage their data products. They can install data products, but they can also then ultimately manage security and governance. Yeah, so it's very important that there's full governance on top of data products, because ultimately SAP data is very important data at the end of the day, and therefore you have to make sure that it's fully governed and that only privileged users have access to the data. Then there is BW, where now Business Data Cloud actually also offers the way forward for BW customers into a fully managed cloud solution. So BW Private Cloud Edition is actually enhanced with a component called Data Product Generator, which allows us to replicate from BW-based artifacts like info cubes directly into the object store underneath Business Data Cloud, and then create data products out of this automatically. This is also managed in Datasphere as the customer-facing environment. I guess I don't have to introduce Datasphere because this is widely known, I assume. Yeah, and obviously Datasphere is a native citizen within the Business Data Cloud stack, and so is Analytics Cloud as well. So the power couple of SAC and Datasphere actually enables analytic consumption through Datasphere, where we manage then basically the cubes directly down to the data products. And I will show an example later to show this integration actually. And then as a new component in the stack, on the right-hand side, you see SAP Databricks. SAP Databricks is an OEM solution of Databricks, and it's very tightly integrated with the SAP stack. We actually apply a zero copy mechanism, which means the data products managed in the object store can be shared with Databricks. And I also have an example later on how this works. They can be shared with Databricks so that customers can use Databricks in order to manage their ML AI capabilities. Yeah, there's the full-fledged notebook capabilities available, which customers typically love about Databricks. And it also allows to share back data, which got created in Databricks with Business Data Cloud, in order to combine it with other services like Datasphere and SAC. For instance, things like a plan actual comparison. So if you had an ML model running in Databricks, creating some new insights on top of the data set, this can then again be shared back with the SAP stack without copying the data. Now, on top of this, there is then a set of intelligent applications which are shipped by SAP, but which also will be enabled and opened for partners and customers at the end of the day. And there's basically two flavors of intelligent apps. There is the content-based applications. For instance, a working capital dashboard, which we ship out of BDC, is based on content which runs in SAP Analytics Cloud and Datasphere. This is consuming data products from S4, basically. Things like sales orders are consumed there. But in addition, we're now also working on a first wave of intelligent applications which are pro-code based. The first wave of these intelligent apps got announced at SAP Connect basically 2 weeks ago in Las Vegas. And those applications are based on CAP as our programming model from BTP. And CAP is now enhanced as we speak in order to learn how to consume and produce data products. And this is how we bring the entire stack together. And this is also how we unblock customers and partners to easily tap into the SAP data world at the end of the day. All right, so let's look at the architecture and the principles which we actually applied. So before we go into the machinery, let's quickly do a level setting on data products as such. So as I already mentioned, data products are based on a common open API set. Yeah. So basically what we do when we create a data product, we create in the object store delta tables, which actually reflect the raw data set. We manage these data sets. We transform it into a delta table. And in order then to allow consumption both from Datasphere and Databricks, but also for intelligent apps, we put a so-called delta share in place, which is a very defined sharing mechanism, how you can get access to the data managed in the object store. So you can think about delta share as something like a key, a time-based key, which you give someone to your house or to a hotel room, for instance, right? So if you go to a hotel, very often you find these digital keys now where you get access to your room, but only for a specific time frame. And the same mechanism you actually can apply to a delta share. That's more or less the same thing on a technical level. Then by applying these open standards and open APIs, we also then allow easy integration with vendors like Databricks, but also with other vendors like Google. So for instance, Google BigQuery was also announced at SAP Connect 2 weeks ago. And this is also where you can see that we really want to foster and establish an open ecosystem around Business Data Cloud, making it possible for customers to use SAP data also in combination with non-SAP data and even with non-SAP tools. Because this is also what we find very often when we talk to customers. Customers have their existing tool landscape, and we don't want to lock this down. Yeah. Now, it's very important to understand that we also provide a fully discoverable mechanisms for these data products. So that means a service like UCL, which I was already introducing later on, actually caters as a central directory, which is a global directory, which then holds the information in terms of metadata for all available data products in a customer environment. Yeah. And ultimately, through open resource discovery, which is an open source protocol, we then describe the semantics of the data products in a human readable way. There's two flavors of data products. Starting at the bottom, you find the so-called primary data products. So if you think about the source system, like in that case, for instance, S4 finance or skills coming from SuccessFactors, we actually transform the source data sets into so-called primary data products, which basically reflect the source data more or less one-to-one. There is some transformation typically needed in order to transform these data products into a stable API layer. And that's what we then call primary data products. So these data products, when customers install them in their landscape, these data products actually then contain the so-called canonical data model. This is the data model which SAP ships as part of its standard content. So when we install S4 in the customer landscape, then customers typically have the canonical definition of a data product, but then typically customers also start to extend their systems. So they highly extend S4, they introduce new columns to these data sets, they even change some columns, right? And all of these extensions, we automatically pick them up when we install a data product in the actual customer environment. Yeah. Now, on top of this, there's then so-called derived data products. And derived data products, you can think about it as a combination of multiple data products. So for instance, you could now, if you want to build a marketing campaign, you could now start to combine revenue numbers with marketing costs coming from various different data products. They can either be from one LOB solution, but they could also span, and that's what you see on the right-hand side in terms of the spend behavior. They could even spend multiple different LOB source systems. And this is a layering which we actually then apply on top of these data products in order to also allow for things like industry solutions. Yeah. Now let's fast forward a bit because time is flying. So this is actually how open resource discovery looks like. And I'm jumping over this now rather quickly because I also want to make sure that we have enough time for the architecture itself. So a data product actually consists of input ports and output ports. Input ports are relevant when we create a derived data product. Remember what I showed before. If you want to combine multiple data products with each other and create some new insights on top of this, this is where you would then specify as an input port and would point to an API resource, which itself can be a data product, but it could also be an event resource, for instance. And then data products specify an output port, and the output port basically is the API resource, which is then also fully described in a human readable way along with the open resource discovery document. So the API resource, for instance, could be now a delta share, which then describes how consumers get access to the data set as such. But it could also be an event output structure, or in addition, it can also be a SQL-based output structure. And as we move forward, we will enable more and more API resources on top of data products. Ultimately, data products can then be combined and managed, so to say, in a package, which actually defines then a set of data products which typically semantically belong together. Good. So that being said, as I said, we want to establish a what we call data product economy on top of these data products. That includes the SAP managed data products, which I was already describing, but also the so-called customer managed data products. So actually, we let customers create their own data products. For instance, if you have a customer which still has a lot of ECC systems, on-prem systems, we do not lock this down, but we let customers create their so-called custom managed data products by using DataSphere. We apply the same architecture principles. That means these data products are fully managed in an object store. So customers would then replicate from their ECC system into the cloud-based object store. And then customers could also specify the semantics, which can either be derived from the source system or which can also be amended on top of this. Then ultimately, with applying the zero copy delta share based protocol, we then allow downstream consumption of SAP managed and custom managed data products in the same way. And now finally, let's look at how these data products are being generated from a technical perspective. So I want to draw your attention now to the left-hand side where you find the SAP sources. So remember, for all the SAP sources, we want to offer data products in a fully managed way, in an SAP managed way. In order to achieve that, we actually now ask the LOBs on our side to create so-called data product definition file. That's a DPD file. In order to make this as easy as possible, we have a component in our stack called data product generator. This consumes the source metadata from the various systems, so from S4, from SuccessFactors, Ariba, etc. And we then generate a data product template, if you will, which is then being edited in order to also specify a transformation. So we want to make sure that we can decouple an ingestion layer, which represents the raw data, from a consumption layer, which would be the data product. And that ultimately allows, or no, that requires that we transform the data from whatever internal raw format it might have on the LOB source side into a delta table in order to allow for the downstream consumption. So all of that is then being established in a data product definition file, which is also JSON based. And then we register these data product definition files in a data product registry. This is a central component which then allows to install a data product at customer side during runtime. And if we look at the right-hand side at DataSphere, this is actually where customers would create their own custom managed data products, and those would be then registered as well. Now, let's look at the production then. So let's assume we ship now data products to customers, and then a customer wants to install a set of data products. In this case, it would be 2 data products, basically. So these data products can either be installed automatically by intelligent apps, or customers can manually install these data products by using BDC Cockpit as the administration component. That would actually trigger then the installation through an orchestration layer, which we offer in our landscape. And this orchestration layer then actually gets informed about the installation of a set of data products. And then based on the data product, we know which is the source system on our side. We then call into the source system and inform the source system, for instance, S4, about the installation of a various data product. There is a mapping in the source system which actually maps from the data product name into the internal tables which actually build up the data product. And then S4 or the other source system, they would start to collect the data and then push the data into the object store. So in the middle, you see the lakehouse layer, and we actually apply a medallion architecture. So this medallion architecture allows to decouple the production and the consumption of data. So in the Bronx layer, this is where you find the raw data. That can be CSV files, those could be Parquet files, it could be anything, flat files at the end of the day. And then we take the transformations which were defined in the data product definition file and transform the data sets, the raw data, into what we then call these primary data products. And those are specified in the silver layer. By doing so, you now have the possibility to have data products available as a stable interface to the outside world and completely decouple it from the raw ingestion layer. So that means data gets being pushed on an ongoing basis into the ingestion layer on the Bronx side, and then it's getting transformed as new data arrives. And data products can always be consumed then through stable interface. Now, ultimately, at the top part, you then see the unified customer landscape layer. This is the central registry of data products. And this is where now these data products actually would be exposed through Open Resource Discovery, ORD, as I explained on the slide before. And now finally, let's look at how these data products are being consumed. So we understood the lakehouse layer. We talked about the foundation service, which actually creates the data products. So now let's look at the middle layer, so to say. What you see here is you see DataSphere and Analytics Cloud for analytic consumption in that case from an intelligent app. That would be a content-based intelligent app. But the same would also work for Procode-based, CAP-based intelligent apps. So actually what happens is the administrator triggers the installation through Cockpit. Yeah. That would ultimately start to install the data product, and it would then register in DataSphere this data product for consumption. Technically, what happens then is DataSphere runs on top of HANA Cloud, and HANA Cloud is our compute layer for data products. So what we then do is we create virtual tables in HANA Cloud, in DataSphere in that case, which actually point to the actual data product in the object store. And then with a functionality called SQL on files, you can then actually query these data products. So that means you can run SQL queries against data products, but under the hood, HANA makes sure that the delta tables are actually consumed on the fly from the object store. In addition, we can also cache the data locally in HANA in order to achieve better performance for analytic purposes if needed. But this is a transient cache, and customers can manage this cache. So customers can decide how much data they want to cache and store in memory in order to have it fast, but also what data sets could still be federated at a much lower TCO at the end of the day. And now finally, and I'm running out of time, unfortunately. So finally, let's look also how Databricks would consume data sets and also how it would share back data sets. So it's more or less the same picture. But here in the cockpit, there's a slight difference. So remember, there's cockpit as the administration experience. And in cockpit, now an administrator would select a data product, an SAP data product, and share it with Databricks. We have a component in our stack called BDC Connect, which actually does the plumbing between the SAP stack and the Databricks stack. BDC Connect then also manages the trust between the various systems. And what we then do is we take the open resource discovery file of a data product, which contains the semantics and the output ports to the Delta share, and we register this in Unity Catalog, which is the catalog solution in Databricks. And then from Unity Catalog, the normal Databricks administrator would take these Delta shares, which are registered there, pointing to the data product, and then share it with the business users in Databricks accordingly. A business user would then typically use a notebook in order to, for instance, run some AI ML models on top of this. This business user would then ultimately create a new data set. This is what's depicted here at number 4, this ML data set. And then there is a library, an SDK library in Databricks, which allows to share back this data set through an API with BDC. So this data set then ultimately would be registered also through an ORD document in Unified Customer Landscape. And with this, downstream consumption, for instance, in DataSphere, which you see at number 5 here, is fully available. And then the normal consumption process through virtual tables, etc., would kick in. Yeah. So now summing up, what you can see is by applying these Lakehouse architecture principles and open standards, we actually achieve that we can consume data products from SAP products, but also beyond SAP products. So there's the integration with Databricks available. At Connect, we announced the integration with Google BigQuery, and this is how we now want to foster an open ecosystem approach. Closing down, you will find some more information about Business Data Cloud and data products at the links I provided here. And with that, I would now open it up for questions and answers. Thanks.
Thank you, Bjorn, for very detailed overview, starting from the high level all the way to the bottom details. Typical question, as we should expect, can these slides be shared? If yes, you can send them to me and I will post them on the event page. Is that doable?
I think so. Let me clarify this, but I guess those are shareable. Yes.
Okay, thank you. There was SAP knowledge graph shown on the high level
Mhm.
slides. What is its purpose in this
Yeah,
architecture?
I can talk about this. So the knowledge graph is actually what we need in order to instruct the LLM and ground the LLM with the semantic richness of data products. So LLMs are general purpose typically, right? But if you now want AI agents, for instance, to consume data products, you actually need to instruct the agents how these data products can be consumed. Otherwise, the agents would very easily just hallucinate and do something. And this is exactly where now the knowledge graph kicks in, because the knowledge graph is then used for grounding with the LLM. It's provided through the HANA Cloud knowledge graph capabilities. What we do there is we basically feed the knowledge graph with the data product, with the open resource discovery documents from data products. And then the LLM is able to, first of all, discover data products based on natural language queries. For instance, a customer could now ask, what was my revenue in 24? Yeah, and then by using the knowledge graph as a kind of dictionary, but also for grounding, the LLM would be able to find out, oh, there is a sales order data product, which I could actually use in order to answer this query. This is how we then basically use the knowledge graph in order to stop the hallucination at the AI side.
Okay. As well in chat, I shared two previous links to two previous sessions during this Oktoberfest about the data products and about enriching data products with SAP Databricks. Uh, the question is the data replicated from BDC HDLF to DataSphere?
It can be replicated. That's what I was talking about, the
Mhm.
access layer and data sphere. There's two options. You can either federate through virtual tables and then actually federate into the object store. That means we run SQL queries on the fly. We call this component SQL on files because it basically applies SQL on top of files. So that's one option. And the other option is you can replicate data from the object store into DataSphere in memory. This is in order to improve query performance because we need to understand there are physics in the way. So if you have data sitting in the object store, there's network latency between HANA as a compute layer and the object store. HANA would need to read the files on the fly. So the better you specify your filter conditions in a query, the better also the performance typically is, because what delta tables actually do is they contain a dictionary where the optimizer in HANA then can tap into and knows, oh, I need to load sales order from the year 24, for instance. And then based on this dictionary, HANA will know which of the files are actually negligible for the year 24, and the other files would just be discarded. But if this query performance is not fast enough, then you can still replicate into DataSphere in memory and then use full in-memory performance.
Okay, thank you. General question for people who are coming from BW or DataSphere already technical background, what are the areas of knowledge or skills you would recommend to invest to better understand BDC?
Well, I would definitely recommend to familiarize with data products and how data
Mhm.
products are built. But then also for consumption of data products, I would definitely recommend to read into delta tables and delta share as a protocol.
Okay, thank you. So the only other things I would like to remind is that in chat I posted the link to the validation question. So those of you who participate in our uh, Devtoberfest, sorry, because I heard so many terms today during this short session that now I needed to remember the name of the event that we are running. So those of you who participate in the Devtoberfest contest, there is a question from Bjorn, so that you can answer this question and participate in our contest. It's already there. I would like to remind that in 2 weeks, SAP TechEd is happening. And if we don't see you on site in Berlin, then please join SAP TechEd Virtual. There will be a lot of sessions there as well. Björn, are you presenting anything during this TechEd?
No, actually not. I have other meetings, unfortunately. So I won't be at TechEd this year.
Okay, sorry to miss you there, but there will be other people from Business Data Cloud product team. There are, I believe, seven hands-on sessions in Berlin. And if you miss the Berlin session, then because you live in the other part of the world, we will have as well SAP TechEd on tour in Sydney and Bengaluru and in the US happening in November as well. So a lot of content, great session today, a lot of references to build your knowledge and practice it, and a lot of chances to meet and discuss directly with product experts at different events. Peter Nielsen says, thank you for the great presentation. I can just echo this.
Thank you.
Björn, once again, thank you for joining. Everyone else, have a good day and please join our other sessions as well. Take care.
All right. Thanks for having me. Bye-bye.
Okay, I stopped translating.